Hello, everybody. I'm Antonio Yuste from the University of Malaga, and I'm about to present joint work with my PhD supervisor, Alfredo Burrieza, entitled An Awareness Epistemic Framework for Belief Argumentation and Their Dynamics. So let me start with a bit of context and motivation. The motivation of the work is rather conceptual, and it can be summarized in the following claim, saying that there are two intuitive principles governing belief formation and argument evaluation that can potentially clash, right? And these principles are P1, saying that belief formation is conditioned by argument evaluation. This can receive many intuitive readings, but the one we focus on today is that belief sentences should be the conclusions of arguments considered somehow good or strong by the agent. And P2 says that argument evaluation is conditioned by belief formation. Again, this can receive many intuitive or acceptable readings, but the one we focus on today is that premises that are believed should be preferred by the agent to premises that are not believed. So both principles are seems acceptable, maybe rather trivial, but the problem here is when we ask what goes first, P1 or P2, or what goes first, belief formation or argument evaluation. And if we don't want to give any kind of priority to any of the principles, then we have an infinite regress problem. Let me illustrate this idea. So beliefs of a rational agent are based on, and we applied P2, and we get that they are based on good arguments, but these good arguments are rooted instead in belief premises, applying P2. And these beliefs are based on applying P1, we get good arguments again. And as you can imagine, this goes on indefinitely. So, of course, we have not discovered the wheel. An analogous problem is in the root of a long-standing debate within epistemology about the structure of epistemic justification. And there are many possible solutions to this, but fundationalist solution or fundationalism propose to accept both principles, but give some sort of priority to P2. So there are some kinds of basic beliefs in our terms. If you read the tension between both principles in argumentative terms, there are non-argumentative beliefs, right? And it is curious that there is a similar distinction in terms of intuitive and inferred beliefs developed by Sperbeck in the late 90s and inspired in cognitive science. And I point this out because the very same distinction is at the core of the influential argumentative theory of reason developed by Sperbeck and Mercier in a few years ago. All right. So note that P1, the idea that the beliefs of the agent should be grounded on reasons or arguments, is the spark that motivates the recent efforts of the epistemic logic community to include the missing justification components into their formal models of beliefs and knowledge and other epistemic attitudes. And there has been several trials for this, heterogeneous approaches. The most famous being justification logic, in which justification are understood as syntactic objects. We have more semantics options, as the logics of evidence, in which justification are treated as semantic objects, so as sets of words in a Kripke model. And yet a third natural candidate for formalizing the notion of justification is using formal argumentation and plug this formal argumentation component into the epistemic logic models. So the underlying idea here is that a justification is a good or a strong enough argument. There has been many proposals, but most of them share the idea that arguments are either semantic objects or primitive atomic entities with a semantic character. And last year in Comma, in the last edition of Comma, we proposed an alternative to this approach, in which arguments are understood as syntactic entities, as done in the field of structured formal argumentation. So in the present paper, we we developed our previous work, our common paper, in which we provided an awareness epistemic logic framework to capture both basic and argument-based belief. And the present paper builds upon it in 3 different directions. We provided a better contextualization that I just depicted during the first minutes of the talk. We provided also more technical results, specifically completeness and rationality postulates for argument-based beliefs. And we implement different kinds of dynamics using tools from dynamic epistemic logic. So that was the context and motivation, and this is the outline of the rest of the talk. I will talk about the static logic, then I will move to how the different kinds of beliefs can be captured in this formal language. Then I will mention what kind of dynamics we have studied, and I will finish in by saying a bit more about our results and actual challenges and future work. All right. So about the static framework, we developed it in the common paper. It has mainly three principal ingredients, which are awareness plus active logic, has started by Fagin and Halpern in the late 80s. Aspect plus argumentation. Aspect plus is a famous formalism for structured argumentation developed by Motgiela and Praken. And also we use the dynamic of awareness tradition, more in particular the approach by Grossi and Velázquez Quesada for modeling dynamics of information in our framework. So just a bit for get some flavor of the technical details, let me present our formal language. We departed from a countably infinite set of atoms. And our language has 2 kind of entities, formulas and arguments, and these are given by mutual recursion. As for formulas, we have Boolean propositional logic in the base, a modal operator that will be used to model one kind of basic beliefs, and then all these operators that has arguments on it in them, right? So note by the use of colors, blues correspond to awareness logic and purple to aspect argumentation, that the awareness operator, this here is the formal bridge between the 2 kind of formalisms. So this means that the agent is aware of an argument alpha. This means that argument alpha is well shaped, so has been constructed properly in the sense that all deductive use of the deductive rules used on it in it are valid, and all diffeasible rules are acceptable. Then this means that alpha undercuts beta, so alpha attacks a diffeasible inference step of beta. The conclusion of alpha is phi, and alpha is a strict argument, so it contains no diffeasible step. So arguments are built in 3 inductive steps. Every formula written between these angle brackets is an argument, but note that this is a rather mathematical concept more than real life argument, because of course we wouldn't say that it rains because it rains. So it rains is a reason for believing that it rains, right? So it's more an extreme case, but we need it for the recursion. And then we have more complex arguments, more similar to the arguments we see in real life as products of argumentation. So this means that phi follows deductively in the sense, or strictly in the sense of in classic propositional logic from the conclusions of alpha 1, alpha n, which are arguments also. And this means that phi follows from presumptively or diffusively from the conclusions of alpha 1, alpha n. All right, so I'm not going to show you the formal semantics for this language, but we basically use the idea of including syntactic components in the model. This idea is important from awareness to exacting logic, and we also need to define recursively, depending on the models, a set of well-shaped arguments, and we mimic the definition of aspect plus. But the curious thing here is that this definition can be captured in our language and later in the axiomatics. All right, so what kind of beliefs can we distinguish here? Remember, we were after this distinction between basic beliefs, beliefs that are not based on argumentative reasoning, and argument-based beliefs. So things are actually a bit more complex. As we announced, the model box is used to model basic beliefs, but one really particular kind, because as we use typical Greek semantics, the box suffers from the well-known problem of logical omniscience. So this box represents what the agent would believe if she was a perfect reasoner and is closed under logical consequence, right? We have a more realistic counterpart, and we mimic the definition from the awareness logic literature with a small difference. Since we don't have awareness of sentence, we can simulate the classic definition of explicit belief as implicit belief that phi plus awareness that phi. Here is plus awareness that anatomic argument that phi, right, containing phi. And now for defining the most basic type of argument-based belief that we call deductive beliefs, we need a bridge between arguments and beliefs, right? And this is going to be nothing but our formalization of P2. So remember that P2 says belief formation, condition, argument, evaluation, but this we qualified this P2 so we don't get the infinite regress argument. So our P2 is actually basic belief formation, or the formation of basic beliefs, condition, argument, evaluation. So how we construct this bridge, we take inspiration of in this work of Baltak and collaborators on justification logic, and we said that doxastically accepted argument is nothing but having a basic implicit belief that all the premises of argument alpha are true, right? And with this notion at hand and the rest of our operators, we can define deductive beliefs. So deductive beliefs are a sort of explicit beliefs which are not basic, but follows deductively from basic explicit beliefs, right? So this is to be read as the agent has a deductive belief on phi based on argument alpha, and it's a short and an abbreviation for the following long formula. The agent is aware of alpha, the agent accepts alpha, in this sense up here. The conclusion of alpha is phi, of course, because phi is the belief sentence. Alpha is strict, so that's why it's a deductive belief, because there is no divisibility here. And alpha is well-shaped, so it has been constructed properly, right? And then for defining more general argument-based beliefs, so our formalization of P1, basically, things are a bit more complex, right? Because we want to capture this idea that the beliefs of a rational agent should be rooted on or grounded on good arguments or strong arguments. But the notion of strong arguments has been analyzed for many years, both in formal and informal argumentation. We follow in particular the nice approach by Berland and collaborators, in which the notion of argument strength or argument goodness is split in three different dimensions or tiers. So in the support tier, how good is the reason provided by an argument to believe the conclusion is implemented in our approach precisely by the formalization of P2 that we see. Actually, things are more difficult because we take into account also the strength of link, and we could even go and make things more complex. But you can look at the paper if you're interested in this. And then the second dimension, the red one, called the dialectical tier, is formalized through the inclusion of different kinds of attacks between arguments. And note that undercutting, attacking an inference link, was a primitive operator in our framework, and the other two, undermining, attacking a premise, and rebuttal, attacking a conclusion, can be defined within our language. So using these two notions, we can define the one of argumentative defeat, and when this is restricted to the awareness sets of the agent in a particular model, we get a Dunk's argumentation framework. And then finally, to this argumentation framework, we can apply our favorite argumentative semantics. In this work, we have taken the grounded semantics because it has been argued to be the most suitable one for dealing with epistemic reasoning. And this provides what Berlin and collaborators call the evaluative tier of argument evaluation. So finally, argument-based beliefs are defined as so the agent has an argument-based belief that phi is the case if and only if there is an argument in the grounded extension of this argumentation framework concluding phi. So as you see, the definition is complex, and actually we need to introduce a new primitive operator because this one is not definable in our basic static language. And this is a diagram depicting the different inclusions between the four kinds of beliefs we have defined. So note that all basic implicit beliefs are a string case of deductive beliefs, and these in turn are also basic implicit beliefs. So this would be our core beliefs and all deductive consequences, the one that has been computed already by the agent, and the one that can potentially be concluded. And then we have argument-based beliefs, and note that there are elements that might be argument-based beliefs, but not basic implicit beliefs. And the reason is that the agent could have taken some non-deductive inference step from here, right? Okay, let me say a bit about the dynamics, really informal. So our whole approach is modular, and so it is the dynamics also. We have many elements in our models, and we can study different kinds of actions on these elements and then concatenate and combine them in different ways. So we have basically studied four kinds of actions, which are adaptations of actions studied in the literature to our framework. And these are first becoming aware of and forgetting an argument. These are two options, and we believe that these two actions are intuitive in the understanding of a debate in which agents may become aware of new arguments and also forget them because they don't consider them relevant or because they have limited memory. Agents can learn also a new divisible rules that they use not to accept, but they might read it in a book or formulate it from observations and so on. And finally, we have also implemented a public announcement of a sentence phi, which is probably the most well-studied action in dynamic epistemic logic, and we use them as a kind of hard update, right? So update that is first non-argumentative. It comes from observation or communication. A second is a kind of update in which you trust the source as infallible, right? You strongly believe what the source says. All right. So what are the technical results with respect to our common paper? Well, we have axiomatizations, complete axiomatizations of both the argument-based free, static, and dynamic fragments. So the first one is an indirect completeness proof. You can have a look to it if you are interested. And the second one uses ubiquitous reduction actions, like in dynamic epistemic logic. And we have some formal abnormalities. For example, in here, we don't use this is the action of learning a new rule, but curiously, due to the semantics, we don't need to refer to the preconditions of this action. They just commute, and this does not happen with the rest of operators. And we have also provided sufficient conditions for Caminada and good rationality postulates to hold for argument-based beliefs. And we get two kinds of rationality. In this case, the argument-based belief only satisfies two postulates, and in this case, it satisfies the full postulate. So about ongoing and future work, we have basically three branches. Of course, we should study multi-agency because it's the where argumentation gets really interesting. We still have to axiomatize the argument-based belief operators, and this is being challenging, but we hope we can make it. And also a third option would be to include more fine-grained model information so as to study more fine-grained forms of preference between arguments. So that was all. Thank you very much. I passed through the reference in case you want to take a screenshot of